That was definitely a video, right? Not a
It's
picture?
not evil,
All right, good.
You're the one that did it. You took that thing.
Yeah, sure. Okay, so let's first look over what we did already. Okay, so far. That should be like two separate words, huh? So far.
We're really good at write so far.
You should write so far. So far we've studied what have we studied? We studied Boyle's law. It's a nice little review for a second. Boyle's law is P1 V1 equals P2 V2. It's a law that relates pressure to volume in gases. It tells you that if you compress a gas, if you just make the volume smaller, the pressure goes up. And if you make the volume bigger, the pressure goes down. Right? They're inversely proportional. Okay, we have Charles' law. And Charles' law is V1 over T1 equals V2 over T2. And so this relates volume to temperature. It tells us that as we raise the temperature, the volume goes up. And as we lower the temperature, the volume goes down. So they move together. They're proportional. C25. Yes, she's taking a quiz in another classroom. Yeah. That's right next to C26. So the phone number is 262. All right, so there's one more gas law. Yes?
Isn't it true you can get high off this?
No, not that. That's just compressed air.
Right, my mom will beat me trying to get where that's
You set that right there? All right, there's one more gas law that I haven't given you.
India's here.
P1 over T1 equals P2 over T3.
Which one is that?
This one I did not give you. And I'm not going to give you the name of it.
Why?
I don't know, because students think it's funny and it's irritating.
Wait, I want to know.
You got it, though. It is to start with G.
It's pronounced God.
What? You mad because he hates them.
Okay. And we don't the office, the secretary, and the people.
He
And
said,
you need to see what your parents' office remote. Okay. So this is pronounced Guy Lussac.
oh.
Yes. All right, so there are 3 gas laws. This last one relates pressure to temperature, and what this one tells us is that as we raise the temperature of a gas, the pressure increases. So this would be if the volume doesn't expand. So if you keep something in the same volume and you heat it up, then the pressure will increase. All right, so now that we have those 3 together, I can give you the combined gas law. And so the reason I didn't teach this is because you guys get the idea of how to use these things by now. I don't need a program for detail. Combined gas law. Does somebody want to take a wild guess as to what the combined gas law is going to be?
All P1 equals
You were like sort of there, but not exactly. Anybody else?
All combined.
Well, yeah, so what's all in combined going to look like? It's really there's only 3 variables, right? It's going to be
times V1 over T equals.
Yeah. What's that? Okay, now one of the consequences of this is that if we lower pressure, and really it's this law here, if we lower pressure and keep the volume the same, the temperature goes down. And so this I wanted to show you guys, since I don't do the Gay-Lussac law, I'll show it to you for a combined gas law. So this is compressed air, and if I spray some out, what's going to happen to the pressure inside? It'll go down, right? Okay, so everybody who does this want you to spray it like once or twice before you pass it around, or at least the first few people. And tell me what you notice.
We're supposed to squirt it at ourselves.
You don't spray to your classmates. Don't spray to yourself.
You have to
Are
squirt.
you scared?
No, I
Not
just don't want
squirt, I
to.
mean,
It's just cold.
Yeah, it should be very cold. This is actually how air conditioning works, right? You drop the pressure,
Yeah,
and then the tubes get cold.
It's air. I told you it's a can of air.
It's Ebola.
Yes, that's what it is. All right. Yes.
This guy's scared of
So you should notice the more you spray it, the colder it gets. And by the time it gets to the last person, it's going to be almost freezing. There will be condensation on the outside. And so that's, like I said, that's how air conditioning and refrigeration works off that concept. Alright, maybe this is too much fun. Alright, so now it's time to do a problem with this. So let's go ahead and do that. Example 36.2.
really
Okay,
really
let's say
Say 25.
a
You're not gonna do it.
container of gas is not is has a temperature of
37.
27.
Oh.
You know, let's make it something else. So let's make it, because I want it to be Kelvin. Let's make it 270 Kelvin. This way we don't have to sit down. Thank you. This way we don't have to convert anything. So we'll just do Kelvin here. Make our lives easier. Its volume is 45 liters, and the pressure is 701 kPa. Now look, you're looking at the equation, right? How many givens am I going to give you? Nope. There's 6 total, so I'm going to give you 5, right? Otherwise we can't solve for something unless I give you all but 1. If I gave you 2 unknowns, we can never solve for them. So I'm going to have to give you 6 bits of information. So far I gave you P1, V1, T1. Then after it cools, what do I want to leave here? The pressure is what? 500 what? 525 kPa. And the temperature is what? Yeah.
Alright, chill, yo.
200.
104.
Kelvin. No, we can't wait for you anymore. 200 Kelvin. So what is the volume? All right, so let's make some room here because we got some work to do. Let's do this. So the first thing we're going to do, of course, is list our givens. T1, 270 Kelvin. V1 is 45 liters. And the pressure 701 kPa. Okay, so we got all the first ones. After it cools, the pressure is 525, so P2 is 525 kPa. T2 is 200 kPa. And then V2 is question mark. Listen, if you didn't think you needed to list your givens before, I think now you should hopefully realize that you have to list your givens. You're not going to be able to do these problems without it. Unless you're a genius, in which case, I'm going to leave high school and just read
I
it.
felt you too.
Huh?
And just be
Oh, thank you. Okay, so now we need to, we're gonna write it, we'll just write up here. So we need to write our equation and solve it for P2. So we got P1, V1 over T1 equals P2, V2 over T2. What's the first step here in solving for V2? What is it?
Plus you.
No. Well, we got two things here that need to go away, right? So we're going to multiply by T2 first, so it'll go over there. So T2, T2. So then this is going to cancel. And you got to rewrite these things. You can't just try and do it all in one step. You got to rewrite it after each step. T2, P1, V1 over T1 equals P2, V2. What's the last step here? Divide by P2, because that's the only thing left that's next to the V. So divide by P2 over here, you can just put it on the bottom there. These cancel. And then rewrite it again, so it looks neat. Those two steps. I know. This is the grown-up class. We're good now. Alright, so there's your solution. And now we can plug in numbers. And that's a good thing. We listed them all, makes it easier. So we got T2, 200K times P1, 701 kPa, times V1, 270K, divided by T1. Oops, I just screwed up, didn't I?
Yeah,
45. This is going to be 270K, and then P2 is 525. Two things you should notice, or really just one you should focus on. If you see a number twice in here, you might have made a mistake. Just like, I was about to write 270 on top and bottom. Unless it actually shows up twice, no problem. Then it should. All right, so the best way not to make a mistake, multiply all the top, write the number down, multiply the bottom, write the number down, and then divide top by bottom. All right, somebody plug that in and tell me what we get. Yeah, tell me what the top is.
639,309.
Okay, and what's the bottom?
441,750.
Okay. And for a moment, I'm not going to worry about the units because we know what they're going to come out to. It's going to end up being liters. So I'm just going to leave that alone. All right, divide those. We get something like 50 or 60 or 40, something like that.
44.5.
44.5. And that's liters. Questions on that? Okay. So any other problems that I give you, if I ask you for pressure, at the end of the problem, that's P2. If I ask you for the final temperature, that's T2. I'm confident you guys can solve these now. If you can't, just come up and ask you for help. Good?
Yes.
All right.